We're going to solve the linear programming problem using method of corners. So we're going to maximize p equals 3x plus 4y, and subject to 5x plus 5y less than or equal to 35, 8x plus 4y less than or equal to 48, 2x plus 6y less than or equal to 30, x is greater than or equal to 0, and y is greater than or equal to 0. Now we need to find our corner points. We have a corner point here, let's call it A. We have a corner point here, let's call it B. We have a corner point here, call it C. There's a corner point here, D, and E. We need to find the coordinates of all of them. Well, A is easy. It's the origin, 0, 0. B is also easy. It is a y-intercept. We already found all the y-intercepts of all of our lines. It's the y-intercept of 2x plus 6y equal 30. So that one's easy. So B here is 0, 5. A is 0, 0. We don't know what C is yet, and we don't know what D is yet. E is also easy. It is an intercept. It is the intercept. Follow the line to where it's labeled. The intercept of 8x plus 4y equal 48. So if it's crossing the x-axis, that means y is 0. You are solving 8x equals 48. X is 6. And yes, that's what we've labeled. So this point right here is 6, 0. We need to figure out the points for C and D. So for part C, we're going to figure out which lines we're going to use. We're going to find point C, and we're going to follow the lines to where they're labeled. See, there's an X. So we're going to go back here and say, okay, we're going to use this line, 5x plus 5y equal 35. Okay, and then go back to where the X is. We're going to go here. We're going to go this way to see where this line is labeled. 2x plus 6y equals 30. We're going to solve that system of equations. When we solve this system, we want the coefficients of one of the variables to be the same but the opposite sign. So I'm just going to choose to multiply the top one by 2. We're going to get rid of the x's. Multiply the top one by 2. And we're going to multiply the bottom one by a negative 5 on both sides. When we do this, we end up with 10x plus 10y equals 70. Then we get negative 10x minus 30y equals 150. The x's cancel. We get negative 20y equals negative 80. So y is 4. So you plug 4 into either equation to get the x. So 2x plus 6 times 4 equals 30. So 2x plus 24 equals 30. There's some plug into this one. 2x equals, what's that, 6? X is 3. Then you look at the point C. Does it look like the point could be 3, 4? So here's C. My picture is not perfectly to scale, but sure, the x coordinate could definitely be 3. It's between 2 and 4, looks like here. And the y coordinate looks like 4, so 3, 4. We do the same thing for D. So for point D, we're going to follow the x to where it's labeled. So D, if we looked all the way where it's labeled, we see we have 8x plus 4y equal 48. And then start back in the middle. Where is it labeled? Follow D. Okay, we didn't label it this way, so now we're looking at this purple line. 5x plus 5y equal 35. We want the coefficients of either x or y, doesn't really matter, to be the same, but we want them to have different signs. So the numbers are smaller for the y's. I have a 4 and a 5, so I'm going to choose to get rid of the y's. Doesn't really matter. So 4, I have 4y, and the other one's 5y, so I'm going to multiply for the least common multiple would be 20. So I'm going to multiply the top one by 5, and the bottom one I'm going to multiply by a negative 4. When I do this, I get 40x plus 20y equals 240. And if I do the bottom one, I get negative 20x minus 20y equals 140. Negative 140. So the y's cancel. We're left with 20x is 100. So x is 5. Now we plug that back into either one of the equations to find the y. So I'm going to use the bottom one. 5 times 5 plus 5y equals 35. So 25 plus 5y equals 35. So 5y is equal to 10. Y is 2. Does it seem reasonable that the point is 5, 2? So here's D. Yeah, does seem reasonable the x value is 5 because it looks like my point is somewhere between 4 and 6. And the y value should be 2. Yes, that looks completely appropriate. 5, 2. So we're going to plug these into a chart for method of corners. I make a chart with my corner point and my objective function. So I have A is 0, 0, B is 0, 5, C is 3, 4, D is 5, 2, E was what, 6, 0? Okay, what was my objective function? 3x plus 4y, and I am maximizing. Okay, so each of these corner points is x, y. So, for example, this one, x is 0 and so is y. So we would plug in x equals 0 and y equals 0. So we get 3 times 0 plus 4 times 0. P here is 0. In this P, we get 3 times 0 plus 4 times 5. Well, that's 20. Here we get 3 times 3 plus 4 times 4. That's 9 plus 16, which is 25. For D, we get 3 times 5 plus 4 times 2. That's 15 plus 8, that's 23. And for E, we get P equals 3 times 6 plus 4 times 0. We get 18. We want to maximize this. So which one is the biggest? 25 is bigger than the other numbers. So there's a maximum of P equal 25 when x is 3 and y is 4. And that's our answer. We're also going to talk about what's happening here. What is this actually doing? What does this line P look like? So I just want to sort of reproduce my basic shape of my graph. So, not exactly to scale, but here's what we have. This was A, here's B, here's C, here's D, and here is E. And we were looking at this region right here. This was our feasible set S, which is definitely bounded. So what are we doing? What are we finding here when we're maximizing? Well, we had a maximum function. We were trying to maximize P equals 3x plus 4y, but that's a line, right? So let's solve for y. We're going to leave y where it is and move the x. So minus 3x minus 3x. We see that we get negative 3x plus P equals 4y. Now get the coefficient of y to be 1 divided by 4 divided by 4. So we see y equals negative 3/4 x plus P over 4. We usually write y equals mx plus b like this. So what we're saying is we have this series of lines that all have the slope negative 3/4, and the intercept is different. And we're just trying to figure out what we would have, what our line would look like for different values. We're trying to make P as large as possible, but what we're really looking at is a series of lines. For example, if P is 4, we'd have y equals negative 3/4 x plus 4 over 4. We'd have y equals negative 3/4 x plus 1. We know how to graph that. We would start with the y-intercept, which is 0, 1. So just kind of eyeballing it somewhere here, and your slope would be negative 3/4. So down 1, 2, 3, and right 1, 2, 3, 4. So your graph would look something like this. Okay? And then you say, well, what happens if P is bigger than that? So I'm just picking multiples of 4 just so you can see. What if P is 8? Y equals negative 3/4 x plus 8 over 4. Y equals negative 3/4 x plus 2. So now your intercept would be 2, but your slope would be the same. And we're going to keep doing this. Now remember, P doesn't have to be a multiple of 4. But what we're doing is we're trying to figure out, we are drawing these lines, and we're trying to figure out what value of P gives us a maximum. This is what is happening graphically.